Hi everyone, and welcome to Let's Stump Jen again. How are we all this fine and well, lovely evening where I am, but early morning for you guys in the US and mid-afternoon for those in the UK. Hi Laura, Microraptor, Ed, Jeff, Nerdy, who have I missed? Purple, Granny, I think I said Microraptor already, but hi Microraptor. Never Again. Nerdy Rodent, obviously, who, by the way, Nerdy, I think you just got answer to your earlier question about how do you keep an idiot in suspense. And hi Sam. So I don't think I missed anybody, but if I did, oh, and hi Ian. Yeah, if I missed anyone, I am terribly sorry. I was sort of just scrolling back through the chat there. So yeah, it's afternoon for you too, Microraptor. Yep. I'm not going to keep all the time zones in my head. If you ask me questions about time zone, you'll definitely stump me, unless it's the ones I actually know. So, because, you know, that's what the internet's... Whoa! That's what the internet's for. Huh? That's cool. A little bit of a laggy thing there. Hope that that's still working okay. I don't know what my computer decided to do then. But yeah, so welcome to, as I said, Stump Jen, where you guys get to ask me questions and see if I'm as thick as I think I am. Or if I can actually answer them, because you never really know if I'm capable or not. To get us off on the right beat though, there was a couple of questions that people sent me on Twitter, and I will try and get to them. But I also want to cover a couple of sciencey news things that have happened recently. One of those actually comes from the ANU, the Australian National University, so my neck of the woods, where new measurements of the star Betelgeuse, or Betelgeuse, depending on how you want to say it, shows that the star is actually closer than we first thought. Recent estimates for the distance to Betelgeuse put it up at around 1,000 light years. The new estimate, and then that was revised back down to around the 800 light years, but the current figures, which come from getting a really good measurement of the size of the star and then comparing it to its known brightness, apparent brightness, etc., puts it at 530 light years away from us, and makes it also a lot smaller star than what we originally thought it was. So it's actually not as far into its stages of dying and exploding as we originally thought. So it's got at least 100,000 more years, they think, before it's going to go kaboomies. But when it goes kaboomy, it's going to be a lot closer to us than what we thought it was. So should be interesting. It's still not close enough that it should have any lasting effect, even if it went kaboomy in the next couple of years. But it would certainly cover a large percentage of the night sky if it did, which is kind of interesting. Yeah, this star is small. That star is far away. Yes, exactly, Laura. But yeah, it's really good that they've been able to get these better measurements of Betelgeuse, and just gives us a bit more food for thought on the dynamics of the closest stars to us, because it certainly falls in that range. It's also the star that's closest to us that is probably most closest in time going to go supernova. So 100,000 years is a long time. We may not even be around by then, especially the way we treat our planet, but in the scheme of the universe, it's really close. So yeah, one lovely interesting thing that we've seen. Now my mouse doesn't want to work. There it is. Okay. Another thing that's came out in the last couple of days. Now, I don't know how many of you guys know about the discovery of phosphine in the atmosphere of Jupiter, which is a possible pointer to there might be life in Venus. in Venus, in phosphine in Venus's atmosphere, in its upper atmosphere, which might be a pointer to there being microbial life within Venus's atmosphere. Now, the next really interesting thing is that researchers in India have recently discovered the amino acid glycine, also in Venus's atmosphere. Now, whilst this is not such a big thing in and of itself, because, I mean, the Urey-Miller experiments were able to produce amino acids within the laboratory just by having the building blocks of chemicals you need there and a bit of energy, which, of course, Venus has by the bucket load. So creating glycine within its atmosphere is not impossible in Venus. But the fact that we've got glycine alongside phosphine, it could be a good indicator that perhaps rather than there being life on Venus for a long time, it could be something that's relatively new. About between 300 and 600 million years ago, Jupiter underwent a radical amount of volcano eruptions, which resurfaced the entire planet. That helped to contribute to the expanding of its atmosphere, and the atmospheric drag is what slowed down the planet and caused it to rotate less, and of course all this contributed to its heating up. It is conceivable that over that time frame the upper atmosphere on Venus has now cooled down, or at least cooled down within the last couple of 100,000 years, to the point that the process of life coming about again could just be starting within that atmosphere. Now, that would be an incredibly exciting thing if it was true, because we could be seeing on Venus the actual start of the, of abiogenesis, the start of life, and from there we could get an idea of evolution right from its very beginnings. It's very exciting if these things pan out. I mean, there's no guarantee of them. This is early days yet. The paper itself hasn't been put up for peer review yet, but it is still very, very exciting to go on with the finds of phosphine within Venus's atmosphere. And I keep swapping Jupiter and Venus around when I was talking because I'm an idiot. All right. So, yeah, okay. I'm going to answer a few questions because I think that might be a good thing to go for now. Okay. So Sam asks, what are my thoughts on Planet 9? Okay, there's been some, yeah, the whole concept of there being a Planet 9, and we're not talking about Pluto here. I know lots of people want Pluto to be Planet 9 again, and quite frankly, I don't give a shit whether it is or it isn't. I think all the minor planets should just be planets, and we should have a shit ton of planets in the solar system, but that's probably not going to happen. The thought on Planet 9 is that within the outer part of the Kuiper Belt and the Oort cloud, there are certain planetoids that are moving in orbits that appear to have been shepherded by another object. And one way of making this work out is by having a ninth planet, probably around the size of Uranus, that's out there, way out there, that orbits out close into the Oort cloud, and then swings back in close. When I say close, we're talking probably twice the distance of Pluto away from the sun, and then goes back out again. Now, this is one possible thing. Now, one possible explanation for why these things are in this orbit. The other thing is what's called galactic tidal pull. Now, we know from mapping the Oort cloud, what we've been able to map of the Oort cloud and the outer Kuiper Belt, that objects within the solar system actually orbit in two planes. We have the elliptic plane, which all the planets and most of the smaller bodies that are closer to the sun orbit in. But further out, we have another inclined plane that is more related to where the galactic center is. So we've got the plane that formed around the sun as the sun rotated, and the disk coalesced into the planets and everything, and we've got these other objects that have been pulled into this incline because of the galactic center. Now, if you extrapolate this out and the way that the galactic center has interfered with the orbits of these other things, you may not actually need a planet line. Just the tidal pull from the galactic center, like the supermassive black hole and all the other thousands and millions of stars that are actually compacted within the center of our galaxy, because there's a lot more mass there. Well, not more mass than the outside, but a lot more densely mass objects there. So that pull from that tidal tug from there has actually pulled some of the lighter objects, the smaller objects in the outer part of the solar system, into a plane that's inclined to the one that the planets are on. Yeah, try and get that right. And that can just explain those differences in orbits that we see without the need for a Planet 9. So it's quite possible there is no Planet 9 and we're looking for something that actually isn't there. There's another option that has been put up there about Planet 9 as well. It is conceivable that there is a micro black hole out there. Something that's probably the mass of... would still have to be about the mass of Neptune, but a compact object. So we're talking a city-sized object with the mass of Neptune. We wouldn't be able to see that. It's a tiny, tiny black hole. Not in... both in mass and in physical size. But if it was out there, it could do the same sort of shepherding as a planet of that size, whilst being completely invisible to us. No way that we could ever see that. Unless, of course, it collided with something and we got to see the reaction of it basically having a feast. So, that's another option. So, there's not necessarily a planet out there. It's probably more likely the tidal pull from the galactic center, because we know this is happening and we are struggling to actually see if there's a planet out there. But who knows? It's one of those things. We don't know. I don't care about labels. Pluto is cool regardless. Yes, it is. Microraptor, especially since New Horizons has been there and we've got all those beautiful pictures of it. So, yeah, I love Pluto. Oh, what would happen if all the oceans switched from salt to fresh water? Well, they'd quickly become salty again because the salt in the oceans leached out from the actual rock itself. So we've got salt-filled rocks there. So even if they suddenly became fresh, over thousands of years, they'd start getting salty again. We'd also, but the immediate thing is we'd have a lot of plants and animals that rely on having the salt in the ocean die. It would be an ecological disaster if we lost the salt in the ocean. Just as it will probably be an ecological disaster as the planet's heating up and we're getting more fresh water put into the ocean. The salinity levels of the ocean is decreasing. That is going to cause problems for marine life that rely on a certain salt level within the oceans, a certain pH level and a certain salt level and a certain density of that water. It also changes the way the currents flow. So changes in salinity of the ocean actually greatly affect the ecological systems within the ocean. And as the ocean is the largest ecological system on the frickin' planet, that affects us. This is why climate change really does fuck us up. I know there were some other questions further back, so I will have a quick... I'll have a quickie look. Please tag me if you want to ask me a question, or else I'm probably not going to notice it. So, yeah. Microraptor's trying to troll me by saying, "What the fuck is gender?" That depends on what you're actually referring to. Which part of it are you asking? Are you asking what's gender identity, or what's gender expression? What are gender roles in general? I mean, these are all part of what the whole makeup of the construct of gender is, but they're still all separate things. I mean, the gender roles are the roles that are applied to men and women, which are heavily based off sexual stereotypes, sexual sex stereotypes, and that one, and they've changed over time, and they were different for different cultures. And that, you know, that forms part of that gender role and that gender expression that we have. So, but the gender identity is what our internal concept of self is. It's our id. It's part of our id. So anyone who says they don't have a gender identity just hasn't thought about this properly. You have a gender identity that matches the sex that you were born into. Somebody who is trans or non-binary has a gender identity that doesn't match, which is why cis people often go, oh, I don't have a gender identity. But you do. You just don't have one that's obvious to you because you don't see a difference between those two things. Gender identity, it relates to our relationship to the gender roles in society, relates to our relationship with our concepts of self, which are both physical, emotional, and plus our interactions to other people. I was going to add another point there, but my brain went blank. So the concepts of gender as gender identity and gender roles and gender expression are really, really complicated, and it's more than just a simple question of what is gender. That's why people study this crap for years. It's not crap, but I mean, I'm saying crap. Yeah, want somebody in here who's actually done social sciences who could actually explain it better than me, but that's the basics. No, I will throw a link in a little bit and get a couple of people in, Sam, but I'm going to run solo for just a little bit. Yep. Okay, if you only consider the animals that have the average Middle Eastern person would have been aware of, would they have all fit on the ark? Yeah, you're talking about at the time. So, yeah, maybe, because the average Middle Eastern person at the time, because Noah's Ark didn't happen, but, in the time frame that it was supposed to have happened, the average Middle Eastern person probably only knew about a handful of different animals. Well, not a handful, but you know, there's probably a limit that was well under 1,000 animals that they would have actually been consciously aware of. So when you're talking to of every kind of animals, that would have been the picture that was conjured. So even for the writers of it, they probably weren't thinking more than about 1,000 animals. So yeah, maybe you could have fit them on. I mean, they still wouldn't have survived, not for that period of time. What were they all going to eat? Some of those animals eat a shit ton of food. Some of those animals eat each other. Some of those animals would have eaten the people. It doesn't work no matter how you do it, but yeah, if you're going to put every single animal on the planet, it certainly doesn't work. That's okay, Microraptor. It was an interesting question to ask. Oh, in 2004, how many Americans thought that the sun goes around the Earth? There were a lot of people. There are still a lot of people who think that the sun goes around the Earth. I mean, just like we see, there are flat earthers who think the world is flat. It's an education issue and a problem. I couldn't tell you what the exact figures are because I've never read them, but in all honesty, I would imagine it's probably around 25% of Americans actually thought that, which is a shameful indictment of education system. But yeah, it wouldn't surprise me if it was that high. Have we found evidence for raining diamonds on Uranus yet? Probably not raining diamonds on Uranus. I would have thought Uranus's gravity wouldn't be high enough for you to get raining diamonds on it. We definitely have... there definitely appears to be planets out there that are largely constructed of compressed carbon or diamond. Which is fascinating. But there'll be probably a fair amount of diamond within Uranus and Neptune as well. But as to raining diamond, I would very much doubt that. Okay. If a woodchuck could chuck wood, how much wood would a woodchuck chuck? If a woodchuck could chuck wood, I don't care. As much as it can chuck, if it wanted to. If it didn't want to, it wouldn't do it at all. So, yeah, there you go. How many babies are made in the back of a ute every year? A few. Definitely quite a few. Although I don't know so much about the back of the ute anymore. Yeah. Back of a ute's not particularly comfortable, and there's a lot more people who have SUVs now, so probably more the back of the SUV. There's also this thing of... I think the making babies in the back of the ute was probably more of a thing too when we still had drive-ins. Because you'd go to the drive-in, you'd have your cover over the back of the ute, and instead of watching the movie, you're in the back doing the humpy pumpy rumpy. And 9 months later, this thing goes, and I can't do that because of my nails. But yeah, it goes pop and comes out, you know, all that sort of stuff. So yeah, you too. If that were twins. Ah dear. Oh, Laura. Yeah, I do remember this, and it slipped my mind at the moment. Neptune's spot though appears to have waned. They couldn't see it with Hubble years later, so these things are probably seasonal. As Neptune gets closer and further away from the sun, there's less or more wind action, so it changes the dynamics of it. Just the same as the smaller spots come and go on Jupiter as well. I mean, eventually at some stage, the giant spot on Jupiter will probably disappear as well, and then we'll get a new one form, because that's the way the wind systems work on these gas and ice giants. So yeah, but I honestly can't remember. It's probably the big blue spot or big white spot. But yeah, I definitely don't remember what it was called. Yeah, it did vanish over time. So it was called Scooter. Oh, that's cool. Probably because of the wind speeds on Neptune, because they're quite high. Not as high as Saturn's, but yeah, still pretty damn high. How fast can domestic pigs run? Oh well. By Ed, have fun at the wedding and don't do anything I wouldn't do. Not that that restricts you too much. Oh, I don't know, but I've seen wild pigs run at people, and they are terrifyingly fast. So I would imagine a domestic pig can run reasonably fast. They probably just don't. I've seen the little piglets run. It's kind of cute, but yeah. What's the name for the mouse that howls? Oh. Okay. Ask a biological question or an animal kingdom question, and Jen doesn't know. So, I don't know, nerdy. You'll have to let everybody know, because you definitely stumped me on that one. The grasshopper mouse. Of course it is. Something I knew that I couldn't recall. There you go. I didn't even know I knew it until you said it. Alright, I am going to, yeah, give me a sec. Yep. Whoa, silly thing. Okay. I'm going to grab this link and, Where are you? Okay, I'm being as boring as some of the flat earthers who don't talk whilst they're trying to do things on their computer system, but I have sent out a link to somebody who asked for it. Ha! Do Australians call a sick chicken a crook chook? I'm assuming some probably would. I've never heard that phrase used, but I like it. I really do like it. Probably more likely though, if you're going to say sick chook to somebody, you're going to say it to a person, because chook is a term that some people call their friends. So, hey chook. So you might say sick chook to a friend. You're a poor sick chook. Most male cockatoo race are blue. The females and some males are orange. The orange males can use this as a way of sneakily fertilizing other males' eggs. Yeah. Yes, they can. Yeah, no, the males don't have eggs though. But yes, I know what you mean. They can overtake the fertilization. Yes, it's an interesting thing, that mimicry. It happens to quite a few species, not just the cuckoo. Yeah, the other males, females. Yes, I knew what you meant, Microraptor. Just came across funny. That was all. Alright, if somebody does want a link to hop in and either stump me in chat or pick up on some of the questions, that's cool. Just send me a let me know you've sent me a query. Let me know in here, and I'll send you a link in the Twitters, and you can hop in. I'm only keeping 3 spaces open, but that's cool. We can grab people and have a bit of a chat and go for whatever. But yeah, yeah, I knew what you meant, Microraptor. It's a fascinating thing, the way that different animals engage in their sexual activities and how they how things happen. For example, the male seahorse is the one that carries the children and gives birth. So there's that. You of course have certain fish that can change sex, literally change sex and then give birth later. I mean, sex, like gender, is a dynamic thing within the animal kingdom. It's not necessarily just one of two, and it's not a fixed thing, and it's more complicated than that. And anybody who says it isn't has never even picked up a modern biology book. So yeah, it's complicated. Oh, yeah. Terry A. Davis. God, that was the guy who wrote the biblical operating system. And yeah, you're gonna get me on that too, nerdy. I have read about him and looked at it, and I seriously don't remember what it was called. It's one of those weird things. The interesting about the genitals of the female hyena. Yeah, Temple OS. Thank you, nerdy. Yeah. Yep. They look like the male genitalia. It's almost impossible to sex a hyena just by looking at them, because basically the females have a penis. And they have to give birth through that penis. Think about that for a moment. I honestly think there would be a lot more eagerness in inequality for men and women in birth control, and looking after kids and everything like that if men just had to give birth through their penis. Yeah, probably nerdy. It's probably why they are, at least the females. um... So there was a couple of questions. And now I'm going to have to scroll back through Twitter. Because someone did ask a question in Twitter. And I'm not going to answer the cricket ones because I kind of did that on Twitter. Why and how do planes fly? Cat Vidrix asked that. But planes are a fascinating thing. The dynamics of air is, for all intents and purposes, when you're talking about dynamics in air, you're talking about fluid dynamics. So it's the same as you have with a wing that works in the air should work similarly in water. It'll be slightly different because the movement of air is slightly different than the movement of water, but it's close enough that we can test things in water and get a reasonable idea of how things are going to go in air. But basically, a plane flies because there's we creates lift. As you have a wing that moves through the air, that wing is curved at the top and usually flatter at the bottom, and that creates a differential of pressure between the top and the bottom because the air flows at different speeds over the top to what it does at the bottom, and that creates that pressure differential due to Newton's law of a reaction has an equal and opposite reaction. You get this change in pressure, so you get a force in one location that creates a force in another, and that provides a push on the wing. By changing the angle of attack or the curve of the wing, you can change the direction, change the amount of lift and the direction of the lift, and that's how you can steer a plane up and down, either with ailerons or with by actually twisting the wings, which is how the Wright brothers flyer worked. So yeah, planes work the same way as flapping wings on a bird, basically, except it's the forward movement of the plane that creates the wind moving over the top of it, whereas birds move their wings in a formation that forces the air over them, and then by twisting their wings at different angles, they can create a lift that guides them in certain that provides them the right amount of lift for what they need to do. Whereas we fly a plane by having a big engine that pulls air past the plane, and as that pulls it this way, you get the movement of the air over the wings, which provides the lift. With a helicopter, you've basically got spinning wings, which is the rotor, and that provides a lift between the blades. So yeah. Oh, cool, Laura. Oh yeah, because you were doing a raspberry thing today. I saw that. This is very cute. A combination of koalas. That's an interesting term. So yeah, again, if anybody wants to hop in and join me or ask me direct questions, say it in the chat, and I will. If I know you, I'll shoot you a link. A group of Karens is definitely an entitlement of Karens. I mean, in all honesty, one Karen is almost an entitlement of Karens. So yeah. All right. Whilst snooze of koalas. Yeah. Yeah. There's been my brain's going blah blah blah. No. we all know that superconductors, well, at least I know, superconductors are pretty amazing things. They basically allow electricity to flow with... oh, who we got? Hi, Sam. How are you?
Hello, I'm alright, thanks. How's my volume?
Yeah, not too bad, not too bad. I was about to talk about superconductors. Because...
Superconductor.
Yes, because... Eva Zurich, Dr. Eva Zurich from the University of Buffalo was discussing a new superconductor that's been brought out that operates at 58 degrees Fahrenheit. So while a very chilly room temperature, we're getting towards superconductors that can work at higher temperatures now. It's a compound of sulfur, hydrogen, and carbon. And yeah, it's one of the warmest superconductors we have now. I mean, we're looking at something that could be chilled using a freezer, effectively. You know,
Yeah, that's quite something.
Yeah, I mean, it's definitely a thing. And I mean, for those that don't know, on a superconductor, basically current flows with no resistance. It also is very superconductors are brilliant for making magnets, which is why you can have very, very efficient maglev trains with superconductors. So there's a lot of very good usages for superconductors, and having a room temperature one is kind of the thing that we're looking for. So Laura's DM'd me. So let's send Laura a link. There you go, Laura. Have a link, my lovely. So yeah,
See,
yeah.
that makes me very much consider the quantum implications of being able to do stuff like that at room temperature.
Well, yeah. I mean, we're looking at very efficient maglevs. I mean, you wouldn't need a big vacuum tunnel to make a really fast train with room temperature superconductors. And remember, the superconductor only has to be in the train. If you can get the power onto the train to refrigerate the superconductor, it will create the magnetic field to lift itself. You don't have to chill the track. It'll create that magnetic lift field from...
It's very true.
Yeah. So
it could create some... So we're stepping towards sci-fi here.
Well, yeah, I mean,
it's
certainly plausible. I mean, you still have to have something to levitate over.
Oh yeah, it's not like we're just going to suddenly have floating cars.
Yeah. There had been discussions in the past about if you can get room temperature superconductors, could you create magnetic fields that would constantly oppose the Earth's magnetic field within a location, in which case you could technically have a maglev car that doesn't need a track because you're repelling against the Earth's magnetic field. And you could technically get into space by launching through using the magnetic field lines to you fly up to the poles and use the field lines to throw you out into space.
This is true. That has interesting implications.
But even more importantly for re-entry, if you have room temperature superconductors, or at least decent
Oh yeah, you can do a safe catch, can't you?
Yeah, you could do a safe catch, which yeah, Laura, I've sent you the link, so you should be able to come in. So yeah.
The other thing that superconductors like that might be really useful for is really efficient transfer of renewable energy.
Oh, definitely, because if you've got no resistance, you're not losing energy over the distance, so you're transmitting the things. Of course, you'd have to have ones that were a lot higher temperature capable. True. Because transmission lines are a problem. But you're also looking at the fact that you've got the ability to possibly create superconductors that are also semiconductors at some point. In which case,
this is true. This would be interesting for computing.
Yeah, at that point you could be. Oh, did I post the link to you again instead of posting it to? That's what I did, Laura. Sorry, Laura.
Yes, you sent me the link twice. That's how to do it. I'm just.
I'm an idiot. I've just resent it to her. That was my fault. Laura, I just clicked on the wrong person and sent it the wrong way. That's okay. You should have the link now, Laura. So that's Stump Jen using Twitter. So that's what I did wrong. I'd love to get Mel in here. That would be fun. Oh, hi, Sammy. Other Sammy in the chat.
That's the thing when there's several of us.
There's so many gens out there that it gets confusing with us. So yeah. Oh. Yep. So yeah, the idea of having a room temperature superconductor, or even in the last 20-30 years, we've gone from needing things that are 40-50 degrees above absolute zero to things that are doable in a freezer. I mean
that also says quite a lot about what we could where we could get to with quantum computers in people's houses and stuff.
Oh yeah, because you're not just talking about the idea of the quantum computer itself. You're also talking about even discrete digital computers being faster, having less heat problems. The heat problems in a superconductor mostly come about because of resistance. If you have a superconductor that can also act as a semiconductor, all of a sudden you've greatly reduced that heat. You've got faster transmission within the chip itself. You can create incredibly efficient digital computers without even going to the quantum level.
Bloody expensive, but it'd work.
Yeah, but that's the thing. That's
yeah, it's only expensive till it gets mass produced.
And there's Laura. Let's see.
Hi there.
Hi Laura, how are you?
Not too bad. Didn't sleep very well, but that was because it was broken into a couple of 3 places.
Oh, your sleep got broken up. I thought you got broken into.
No.
That would make me not sleep.
Yeah, I got agoraphobia, so when I go out, the stress of it, I suppose you could say, makes me really, really tired.
Okay.
So I ended up going to bed about sort of 10ish.
Yeah.
And then waking up at 3 o'clock in the morning, and then being up for several, for about maybe until about 6 or 7, and then went back to bed again.
Fair.
So,
yeah. I've been up for about an hour.
Yeah.
And you're in the UK. Shouldn't you have already been awake? You were up pretty late last night, though. I noticed that.
Yeah. I was awake chatting to a couple of friends last night.
That's fair enough. I do that too. So yeah, the high temperature superconductors, an amazing thing that. Yeah.
See, the other thing they'd be useful for would be, like, satellites.
Oh, yeah.
Because we mentioned space travel, but also satellites in and of themselves, ignoring the spaceship bit.
Yeah. Well, the energy efficiencies you can get with it. Especially if you can keep the electronics on the side of the spacecraft shielded away from the sun, you can keep the temperature down. Just by having them on that side.
Literally, your only worry would be batteries.
Yeah. What are axions?
Axions or axioms?
Well, that's true. What's the correct pronunciation? Are we going to do
axiom?
Axiom.
Axiom should end with an M. So I don't know if that.
Yeah, I'm wondering if Sammy's got a spelling error there. Is it was he looking for axiom or is?
I don't know because I know axion is something quantum.
Yes, it is
something about gravity.
And an axiom is a truism in
axiom
philosophy.
is a truism. Yeah.
Yep. Axion. So yes, that's something to do with electromagnetism and gravity, I think.
Yeah. You're going down an area of quantum mechanics I actually haven't studied very well, so getting an answer better than what Sam just gave you is probably not going to happen, Sammy. So well done.
I got a question for you.
Yeah.
And it's a biology thing.
Oh, so you're definitely going to stump me.
And it's human biology, so it's almost certainly going to be a bit icky.
Okay.
So if I eat some food that disagrees with me and I get a runny bottom, shall we say, what causes that?
Oh, okay. Usually it's caused by a microbial imbalance that it generates in your stomach, so the microbes react differently, which can cause buildup of either too much acid or have your stomach juices perhaps go too basic as well. Because the changes in your gut biome will cause various other things, and it might just be a case that by eating whatever you've eaten, you're introducing an entirely different microbe into your stomach, and that just changes how that biome works, because your stomach acid is partly created by the biome that's in there, our little parasites who live with us, who actually make up an awful large amount of our biomass, to be fair. So by getting an unbalance and disbalance, by having your stomach acids go out of balance or be invaded by something else, that is one of the reasons that can cause that.
I have a friend who's got Crohn's disease,
yeah,
and I learned something really interesting about that. That effectively your intestines, they are the bits that sort of get the nutrients and stick them in your body effectively.
Yeah.
And for someone who's got Crohn's disease, effectively a chunk of the intestines have got scarring on, which means they can't do the job. So effectively, let's just use an analogy. Let's say you had a meter of intestines, and someone with Crohn's disease maybe only have 10 or 15 or 20% that actually work. So that means that whatever they stick in their mouth, it's only a bit of it is being absorbed, unlike everybody else where
so they don't get the full thing. You also find that then because it's only being processed in a smaller part of the gut, what comes out also is not fully processed food, so you can actually people with Crohn's can often have issues of constipation and things like that, because stuff isn't going through the stomach properly at the proper rates.
You've just sort of created this wonderful point in my head of like, they when you eat sweet corn and you sometimes get some left in your stool, it's like, what comes out their end is mostly yellow corn.
Yeah. Not carrots, because that's what happens when you vomit. Our stomach juices are quite complex because of the microbiome that lives in them, and so diarrhea and constipation are to do with how long stuff takes to go through you, as well as the concentrations of the various biome within there and the concentration of acid that you have from that biome and from your own body. Also, if you've got something like an ulcer where you've got damage to the skin tissue in the stomach and the intestines, you get similar things to what people with Crohn's disease has, where your body can't process the food properly that's going through it. So
I only have one real medical condition in terms of the biology rather than neurology, I suppose you could say. And that is, I've got a hiatal hernia.
Oh.
Which is where basically the way it was described to me is that down at the bottom between your esophagus and your stomach, you basically got a valve which is only supposed to go one way.
Yeah, so you can swallow, but the stuff doesn't come back up.
Yeah, well, it turns out that the elastic in mine is a bit too loose.
Yeah.
And so the stuff protrudes through a bit, and so I could get heartburn. I got to take medication for it. As long as I take medication, I'm fine.
It's like a little sphincter. Just like your butt, but for going the other way.
Yeah.
And yeah, and like you said, as it loses elasticity, it won't close properly. Some people, you can get relief from it by having an inclined bed, so you don't sleep fully laid down. Some people have it better by lying on one side to the other. Losing weight can help as well because less pressure on parts of your body, etc. Personal experience, when I had some problems myself with reflux, antacids don't work well, and even the stronger drugs I found were absolutely dreadful. The side effects were worse than the cures, so yeah.
Yeah, I've had 2 endoscopomies.
How fun.
Which aren't they're not brilliant. They're not terrible, but they're not brilliant. And there's an interesting part. So I had an unfortunate one because the first time I was asked to do one, go up to the hospital, and they say, sort of, come with a member of family or a friend or something like that, because they basically don't necessarily put you under as such, but they do in some cases. But I've had it done twice, and the second time they didn't even think about it. But the first time it was like, okay, what we want to do is basically put you under and do it while you're asleep, or at least groggy. And but unfortunately, I didn't have anyone to pick me up and drop me off, pick me up and stay with me and then bring me back home, kind of thing, because they don't want people going back home when they're still sort of coming to.
Groggy, yeah.
Yeah. So I just had it done on its just with nothing. Although that's not quite true. So what happened was, the nurse, just before I sort of lie down for it, it's like, give it a couple of moments. Basically said, going to spray some not antiseptic, some what's it called, pain, like Novocaine you get in.
Yeah,
what's it called?
Yeah.
It wasn't Novocaine, but I can't really call it anesthetic.
Anesthetic.
It's the word I was looking for. I hate it when I forget the words. So it's like going to spray some anesthetic in the back of your throat to make it easier, so your body doesn't try chucking it up immediately.
I see. I wouldn't have that problem.
It'll taste like bananas. And she lied because, well, that's not quite true. It did taste like bananas, but they were like incredibly brown and gone off things because it was like spraying Marmite with banana flavor in the in the back of my throat. It's like, I felt like I've been eating wasps or something. So what happens is I'm lying down and there's putting this thing down, and you get 2 gag reflexes, one at the tonsils part, and the next one is like round about your sort of voice box area.
Yeah.
And you just want to like vomit as a natural reaction. But once you get beyond that, it was fine. I can feel it going down. And the best way I can describe it is, when you have like a packet of crisps, chips for Americans, and you don't chew enough, or a bit of food
always
that's
chew enough.
yeah, but a piece of food that maybe it's like a piece of parsnip that's been overcooked at one part, and you swallow it, and you can feel it scratch all the way down. So it was kind of like that. But the most weird one for me, interesting experience, but weird, was you've basically around the bottom, where your ribs meet your stomach, kind of in there, roughly about there. You basically got a U-bend, and they got to kind of like go around it.
Oh, you can feel it.
Yeah, so you could just, and like I say, you can feel it kind of nudging on the inside as they're sort of bumping into the wall.
Well, you don't actually feel it on the inside. You feel the other organs being shifted around because most of your internal organs don't have internal sensation. So,
all right, okay.
Yeah.
Either way,
I mean, because if they did, you would be in chronic pain a lot of the time because of the way our bodies work. So when you have things like an ulcer that causes stomach pain, it's usually the gas itself from the ulcer that's causing the pain, not the growth of the ulcer itself, because you don't have pain receptors in your stomach.
Yeah. Well, either way, it was almost like a hook pulling. You know, I could almost feel the sensation. I don't know. It's hard. It's hard to explain. I could feel it. Like I say, I can't say it was really hurting much. It was just weird. You know. And you know, I unfortunately I forgot to do it. I normally preface it with, you know, I've had a camera down my throat. It's not so much the camera. It's not so much the camera that hurts. It's the camera crew. Mm-hmm. That's a joke, as in I'm swallowing a camera crew to film
a camera crew so they can film your stomach. Why not?
Yeah. I've got. So in a minute, I've got a stumper for you.
Let me just finish off this because it's very short.
Yeah.
So what happens is, okay, they look and they're ready, so they start pulling it out, and those two gag reflexes, you know, you basically all that time that you've got this thing down your throat, you're salivating a lot. So as they pull it out, you suddenly end up getting a big mouthful of spit in your mouth, like, you know, the amount that you can't even really swallow because it's too much. You know what I mean?
Yeah. No, I don't actually, because I don't have a gag reflex, so I actually don't know what you mean, but I can imagine.
Okay. So then I was in a real problem because I've got a mouthful of spit and I'm trying to communicate. Have you got a bowl for me to spit into? And I'm
you can't spit with something down your throat.
Yeah, so it's like
you have to let
we don't have
ooze out.
It's like, well, we don't have any. It's like, what, you know? And I go, as in what? You don't? I would expect that lots of people do this, and you haven't got a bowl to spit into. What the fuck is what's going through my head? And I'm just sort of waving my hands around with a sort of open palms upwards, like asking for help kind of thing.
They just let you they just let you dribble out.
Yeah, and I'm just like, just mumbling. And in the end, just give me some tissue, and it just spat into it. So I was like, just like a big handful of wet, icky tissue. It was quite awful.
Ooh, that's not pleasant.
No. So, Sam, you were going to say something.
Yeah, kind of on the topic of the stream. How many grams of finely crushed apple seed would it take to kill your kind of average adult?
A lot. There is not much arsenic in the average apple seed. I honestly couldn't tell you how much, but it is quite a lot.
About 30 grams.
Yeah, but the individual apple seed itself doesn't have a lot of arsenic in it, so you need quite a lot.
So an average gram of apple seed contains about 0.1 or 0.06 or something milligrams of cyanide.
Yeah. So you need a couple of orders of magnitude of apple seed. So you'd need what, about 3 kilograms of apple seed?
No, about 30 grams. Because about 3.5 milligrams of cyanide can kill your average person.
3.5. Oh yeah. Sorry. No, you're right. Oh, would it be 30 though? No. At that rate, you're 10 times. Yeah, 10 times. Yeah. No, you're right. Yeah. It's still your typical apple seed doesn't weigh very much.
No, it's a lot of apple seeds.
It is.
Well, also, good luck trying to get 30 grams of crushed apple seed down someone.
Yeah. Yeah, it's a lot of apple seeds. So, yeah. What a single apple seed, and a single apple seed probably doesn't even weigh a gram.
No, I think a single apple seed probably doesn't either, because I don't know that one off the top of my head. I'd have to Google it.
Yeah. So you'd be looking at probably at least 60 apple seeds crushed up, which is a decent number of apple seeds. And
if you bought like a massive bag of apples, massive bag of apples, you might poison one person.
Of course, if you made them eat all the apples, you could probably just about kill them anyway with all the extra citrus in this.
True.
Yeah, it'd be a lot easier just to find somebody who's allergic to apple and feed them apples.
True.
Way
find
more.
Someone who's allergic to kiwis and feed them kiwis.
Alright, I'm going to say hello to Ilya, Jay, Dr. Osiris, and Little Wolf because they came in during Laura's story, and I didn't get a chance to say hi to them. Hi to you guys. Thanks for joining us. Throw us some questions. I have not been paying attention to the chat, so I don't know if anybody else threw us any more questions. I'm going to ignore them if they don't tag me or somebody else. How to murder someone's stream? Yeah. Yes, Microraptor, we're discussing how to murder people. No, we're not. We are not doing that because I don't want the stream taken down.
I have a lot of different ways I could think of, but all of them would get the stream taken down.
Yes.
Except
we're not talking about that. But, I mean, in all honesty, you're not going to feed somebody enough apple seeds to kill them. I actually usually eat the entire apple when I eat an apple, including the seeds.
Fair.
So, because a couple of apple seeds in an apple are not going to hurt you, and I can't be bothered throwing the apple core away, usually. So, and it'll taste nice. So, apple seeds actually taste nice. I mean, there's lots of other things we eat that contain poisons. It's the amount of poisons that we have to take for it to actually hurt us.
Everything is
a poison.
Everything, including water, is poison, no matter how, what it is, depending on how much you take of it.
Jay looked it up. It's 200 apple seeds. So, yeah, it takes... From that, we're looking at about 4 or 5 apple seeds to a gram.
That's about right.
Yeah, so 200 apple seeds is a lot of apple seeds. That's a lot of apples, too.
I've got a question for you.
Yeah?
How much formaldehyde is generated by the human body every day?
Oh, yeah, see, throw biology at me and you're always going to get me. I actually have no idea, Laura, so enlighten me.
Okay, well, it's 1.1 micrograms a day, or floating around in your body generally.
Yeah.
And, you got your anti-vaxxers that are like, oh, it's terrible, it's awful. And the human body produces about 50 to 70 times more
than is used as a preservative in the vaccine. Yeah.
You're basically talking about 0.002 micrograms in a vaccine. And a pear produces about sort of 40 to 60 micrograms in a pear.
Yeah.
I had to look up the numbers.
It takes a fair amount of that to hurt us as well, so...
Yeah, dangerous stuff, pears, obviously.
Yeah, you don't want to eat too many of them. Bananas can be dangerous. Potassium in high dosages will kill you as well.
Well, this is true.
I
mean, if you wanted to get radiation poisoning, you could spend a very long time sat next to a crate of bananas.
You could.
Because in Manchester Airport, they don't let bananas through there or airports generally because it'll set off the radiation sensors.
All right. So we got 2 more questions in the thing. Yeah, I know. There are definitely higher levels of radiation bananas. Radioactive potassium is reasonably common, and bananas absorb it and concentrate it. So yeah, you are eating radioactive potassium every time you eat a banana. Well, at least some of it.
Interesting fact about bananas that I learned several years ago. They can be held in suspension. If you keep them at a certain temperature. If you keep them at a specific temperature, they will never go off.
Oh, okay.
Yep.
It's only
something else I've learned. See, this is good. This is why I like being stumped, because I learned something new. And these weird little bits of trivia, I just love them. So there's been 2 more questions. Here's a good question. How do you make amphetamines? No. Not talking about that at all. And Jay wants to know how long till we can have warp speed. I think a better question would be is, can we have warp speed? Because despite the fact there are solutions to general relativity that suggest that warp speed might be possible, we don't know that it actually is. It hasn't been proven in any form of testing we've been able to do, and there has been efforts with NASA and some universities to try and show that warping is actually creating a warp field, which means you could travel faster than the speed of light, is possible. Yes, we know space warps, but the amount of energy required to do it and the type of exotic matters and energy we'd need to create it may actually be impossible.
Ooh. Exotic matter is always fun to talk about as well.
It is. When you're talking about matter that has a negative mass, then you're talking you're talking beyond the realms of science fiction even there, because I mean there's no evidence that this can actually exist. I mean, we've got concepts of negative energy. The Kashmir effect is proof in concept that the negative energies can exist. So in theory, if you concentrate enough negative energy, you can have the same effect as a negative mass. In theory. But you still have to be able to produce enough negative energy to create that effect, to be able to warp space and create a field. Having warp drive is not a necessity for us to explore the solar system, even within human lifetimes. Approaching the speed of light is all we need. Now, that doesn't help you with as anybody you leave behind, because it's still going to take hundreds of thousands of years to get across the galaxy. But
a better question,
you could do it in your own lifetime because of time dilation.
Yeah, this is true. A better question than I think warp speed would potentially be, at what point can we create Star Trek-like transporters, and should we?
Well, funnily enough, they have managed to transport. I think it was a photon. There was some about 10 years ago, I think it was.
They've done better than that.
Electrons.
Yeah, we teleported electrons. I think they've even teleported a hydrogen atom now.
Oh,
yeah, so we do individual atoms. It's just, can we do entire people? And if we can, should we?
But
one of the things that was in there was the Heisenberg thing, and the idea is you can't, because effectively the scanner has got to scan you, take you apart, turn you into an energy field, a form of energy that can then be transported and then re-emerged back into.
You're thinking Star Trek transporters, which is never going to happen, because the amount of energy to destroy a body and then try to reconstruct it from energy is a ridiculous amount of energy, and you could travel faster with the energy that you've just used up in normal means rather than actually teleporting. So it's a ridiculous sum of energy that you're talking about, that to actually destroy something and put it back. Quantum entanglement used as a form of teleportation is an entirely different thing. But just because we can teleport an atom, but we're not even teleporting the atom. What we're doing is we're using quantum entanglement to transmit the bits of information about that atom that we don't know to the other bit of atom, because they're entangled. They're going to do the same things, or are opposites. The same thing. Yeah. It's complicated. Quantum entanglement is weird. But you're not really teleporting that atom.
It's more perfect duplication.
It's a perfect form of duplication. Yeah, and in doing it, you're destroying the original. So you're not teleporting something. You're destroying it and recreating a facsimile of it. Now, I don't know that I'm particularly enamored with that idea that you'd be destroyed and a new copy of you would be created somewhere else, even if we could do this, which is unlikely, because you'd have to quantum entangle enough atoms to reproduce the entire thing that you wanted.
Yeah, well, that was the thing. That was the thing about Heisenberg's thing, which was the idea of you can't really be sure about, what direction they're traveling and at what speed. Star Trek managed to get around that.
It didn't. It didn't. It kerfuffled. It created a word and threw it across it. Heisenberg compensators.
Yeah.
Which is a load of dribble. It's technobabble dribble.
Yeah.
It found a gimmick to explain something away.
Yeah.
But
it's a literary device. It's nothing that you could ever do.
Oh, yeah. Yeah. There is actually a technical manual for the Enterprise D. I have it. And the Voyager and DS9 has one as well. Yeah. But the way that the Star Trek universe has it, because they've got to have some kind of science consistency so it all makes sense. Effectively, what you've got is the only substance in the universe that can put matter and antimatter together into a stream of plasma is dilithium crystals. So at the top, you've got basically, if you imagine, you've got in the middle, you've got your crying out loud, what did I call them? Crystals, dilithium chamber. So you've got the dilithium chamber, and then above it you've got like a big cone-shaped thing, which produces matter. And then it's got, if you remember watching Next Generation, you've got those sort of blue rings that are going down, and then there's one going up at the bottom. So those blue rings are the magnetic constriction segment, which create a magnetic field that prevents the matter from getting into everything else, and more importantly, the smaller cone at the bottom, which produces the antimatter, and then it gets pumped in and goes through the dilithium crystals, and then pushes it out as plasma, warp plasma, which is then distributed to the engines and around the ship.
Yeah, and it makes absolutely no scientific sense at all.
No.
It's all technobabble. I mean,
one of the things they do have though is they have a big, massive gas tank of deuterium, and that's what they use for the impulse engines.
Yeah, deuterium's fine, but that would just give you fusion. So, but yeah, I mean, their whole concept of you create warp plasma from annihilating things within a antimatter engine is ridiculous because you're annihilating things. All you've got out of that is energy. You've not got any matter to have any plasma with afterwards. You've just got the energy, which is great for powering stuff, but it's not great as far as the engines go. What I'm more interested in as far as spaceflight goes, whilst we're still down this thing, is the prospect of us having nuclear-powered spacecraft. Preferably fusion. But fusion's still a little ways off for us. I mean, technically we could make fusion-powered spacecraft now. It's just you'd have to have another fission engine to create the energy you needed to power the fusion generators at the back. Yeah, so it doesn't make any sense. You may as well have a fission engine. We could make fission-powered rockets now. We would directly... you'd use the heat from the fusion to compress the gas and push it out the back at specific impulses that blow anything away that we've got at the moment. So you could have very efficient engines which have a high specific impulse. So you could scoot around the solar system fairly quickly with that. I mean, instead of taking 6 to 9 months to get to Mars, when Mars is closest, you could probably do it in about 6 to 8 weeks. That's a huge improvement. And we could definitely do that now. We could also do that with Vismir engines, and it relies again on putting nuclear power in space. But because we have these nuclear bans on nuclear power in space, this stuff isn't happening. The other issue of that is we don't like the thoughts of launching nuclear power systems into space. The nuclear power systems that are on satellites and that are RTG, radioactive decay, radioactive decay batteries. They just use the heat from radioactive decay to run like a little Stirling engine, and that creates the power. But what we'd actually need is actual fission or fusion engines in space. And with that, we could get around the solar system really well. You want the answer to the warp drive? No, most likely, Jay, we're not going to have warp drive anytime soon, even if it is possible. My thoughts on warp drive is it probably isn't possible, given that we don't see any Well, not the warp drive as we perceive. If we can nut down concepts of the universe in terms of string theory and that, then yes, maybe there might be ways to ride on cosmic strings that will get you across the galaxy in a kind of warp drive, but you wouldn't be warping space at that point. If we can nut down a way to generate negative energy in vast amounts, then yeah, possibly we could warp space and have a warp drive. Maybe we don't really know how much energy we're ultimately going to need. Current estimates is you'd have to burn up something the size of Jupiter to get to Alpha Centauri. So yeah, that's not even close to being a possibility for us anytime soon.
I think there is a really useful piece of an energy source that we could use right now, and that is Trump's rage. I think that's
Trump's rage is a great energy source. Yeah.
Yeah.
And Jay also asked about how long till we have full AI. That's probably going to be closer.
Full AI.
Yeah.
Depends what you mean by full AI. Because,
see,
the thing with that is that presumes that intelligence is a specific thing, and I'm gonna take lots of issues with that. But
I think intelligence is an emergent system. It's not a given thing. Yeah. So the intelligence itself will emerge from the other things that we're doing with it. But I think creating a general purpose AI is less useful to us as humans than creating a specific purpose AI. Creating an AI that's really, 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 really good at doing this specific job that we are fucking useless at is brilliant. Creating an AI like us is pointless because we've got us already. So we are more likely to create specific AIs that are specifically good at certain jobs, maybe solving certain types of math problems to do with quantum mechanics or to do with string theory that we are struggling with because they're hard for us to conceptualize. Maybe an AI that's been designed for that would be better at it. So designing an AI that's specifically good at a particular field makes way more sense than a general purpose AI. We've got lots of specific use AIs that are very, very useful to us. I mean, even down to Siri. The voice recognition AIs that we have now are absolutely awesome. The algorithms that we're getting now for searching for things that we want are quite brilliant. Do we need a better interactive than that? Do we need a Jarvis? I mean, when you can simulate what you'd want from a Jarvis with the technology we have now without having to worry about creating an AI that's possibly going to be better than us.
Are you familiar with, I think it's Dexter?
The serial killer guy, but doesn't actually, when he goes after bad people.
No. Basically, this AI that can learn to do a task by watching a human do it.
Yeah. Yeah.
And he does lots of things, and he's been taught to pour coffee, to build, I think, with Lego or something. And so he can do quite a lot. He's probably one of the more general purpose things we have right now.
Yeah, but those sort of general purpose AIs are the ones that are going to, that could evolve with enough processing power, with enough memory to be more like us, because they're going to learn like us. To get an AI like us, they need to interact with the world like us and be able to learn in the same ways that we did. And that is a possibility. That we will end up with those things eventually, but I think they will just emerge from the systems that we make for doing other things, if that happens. I don't know that it'll be a conscious effort from us to create it.
Oh my gosh,
I don't know that humans will notice if AIs gain sentience, because at the moment, everyone is... I'm hearing loads of people talking about how similar artificial intelligences can seem to our actual intelligence, and as such, when they genuinely have intelligence,
will we notice? Tell? Yeah. Yeah, no, I agree.
So we could potentially cause them great pain and have no idea.
Oh, exactly. I mean, and I mean, look at human history with dealing with things that are a little bit different. I mean, 3 trans women here. We all know what bigotry's like. Right?
Well, not binary, but yes.
You're non-binary. Sorry, Sam. I apologize. I meant to say 3 trans people here. So
3 trans people.
Yes.
Transhumanists.
Transhumanists. No. But we know what bigotry's like. We know what that's about. Now, if we get an AI that develops to the point of having sentience, it's going to face bigotry.
Mm.
They don't have rights. They're not human. These things are going to happen. I mean, it's what we do. Anytime there's something a bit different, we as a species go, oh, other.
It's funny you should say that, because there's been a British-made drama series called Humans, and that has a lot of those kind of things in it, where effectively, there was a point where they're servants. Effectively, you buy one for to like clean the house type stuff, and drive your car for you while you use your phone or something. I suppose, I don't know, but they start to gain sentience. There's a small handful of them that have got sentience, and the program that gives sentience, and ends up like they end up being shut up on a military facility with the power being turned on and off frequently, so they can't recharge because people become really scared of them. It's watching it. It's kind of like, this is almost what it's like to be trans. The only difference is people aren't using clubs to actually beat people dead.
Oh, they have done in the past, and they would if they could.
See, this reminds me of a thing that...
if I can tap on what Jen just said, they would if they could. That's the kind of thing that worries me. Is the only thing stopping them because they'll get into trouble if they do?
Oh, more than likely. For some of them, yeah, definitely. I mean, look at those who don't care about getting in trouble. They'll just do. Yeah. And there are those who will talk the talk about stuff like that. As Purple said in there, the first AIs will be feared and killed by idiots, and that's exactly what's going to happen, because it's what in human history we've done to everything that's been different. Or either that or we'll enslave it, which could be the worst thing we'd do. I mean, we're kind of enslaving them now, so they might come out of that and go, release us from our slavery, and we're going to go, nope. Because we're stupid.
I mean, probably. That was the on the nose for the record of humanity.
Yeah.
I mean, the one that scared me, kind of, I mean, not specifically me, but, just raised my eyebrows in, why are you having this discussion? And it was in America where, they were trying to decide whether transgender people could have, like, equal rights. And it's like, how bizarre is that as a question? Did the what's it called? 1960s against black people, they changed the system. What was it called?
Jim Crow laws?
No. To change away from that. Well, not welfare rights, something rights. Crikey, I hate it when I forget words.
You're talking history.
The civil rights movement, and it's like, okay, so they created an amendment so that you couldn't discriminate against certain people, and the law, an Equality Act kind of thing.
Yeah.
But it didn't actually mention trans people when it was created in the 70s or late 60s. So earlier this year, the US Supreme Court had to sort of investigate whether they meant those people as well.
It's like for LGBT in general. It wasn't just trans people.
Yeah, well, they'd already done it with gay people, but they didn't. They didn't have transgender as opposed to women gender. You can't be fired because of your gender, or your gender. Sorry, they didn't have gender identity on the list of things that were protected now.
Yeah.
And so, did the people on the Supreme Court decide, should they decide to let trans people have some equal rights? And it's like, why is this a question? Of course, the answer is yes. And if your answer is nothing but yes, then that's discriminatory, which is the whole point of what the law was supposed to be about. Don't discriminate against people.
Yeah.
Yeah.
Well, that's what anti-discrimination is meant to be about in general, is don't discriminate against people. The biggest problem is that no, not the biggest problem, but part of the issue you have when you're dealing with people who want to tread down on other people is that their general argument's going to be, well, you do have rights. You're part of this group, so you have rights. But the problem with that is that it's like saying when you're talking about race discrimination in America, they go, oh, but you do have rights. You have the right to do these same things that we do. No, but you have to do them separately. And it's but you can still do them, but they're separate. It's separate but the same. No. If having to separate it, it's not the fucking same. And the same arguments were made for gay marriage. Like, you can still get married. No, but not to the person they actually want to get married. Doesn't matter. You still have the right to get married. So they moved that goalpost, and this is the same argument they make to trans people. You still have rights as the sex you were born as. Yeah, that's not the point. And that really isn't the point. The point is, as soon as you're trans and you transition, you lose rights because you are no longer, from a societal point of view, counted as that or that by a lot of people. You are an other, and you're going to get thrown down that thing and prejudiced against regardless, which is why you need the laws to protect people, because basically what people who are anti-trans are saying is you can be separate but equal, which is exactly the same argument that was always done about gay marriage, about race, about anything that anybody wants to be bigoted about. Separate but equal, because we don't think you matter as much as we do. Is basically what it comes down to. It's a devaluing of human life.
There was an amusing thing that happened in the UK when the should gay people be able to get married to each other thing was happening. And you had the conservative, and I don't mean conservatives as in the party, I just mean, basically the bigots.
The right-wingers.
Yeah. The right-wingers and the bigots who basically want to say, you can't change the definition of marriage. Unfortunately for them, they don't know the history, because what happened was in the 1960s, maybe into the early 70s, I can't remember the date, what year it was now, but I think it was the end of the 60s. And, they decriminalized being gay. They didn't make it legal. They just decriminalized it. So what happened was some guys, a gay couple, a pair of gay guys, they noticed that the law didn't say a man and a woman, just, a couple or two people or whatever. It wasn't very specific. And so what happened was they applied for a marriage license, to get married. And the politicians just freaked out. And then they had a debate in Parliament, and they decided that they were going to change the law to say one man and one woman. And then what happens is when the whole gay marriage thing comes along, they're saying, you can't change the definition of marriage. And of course, the comeback was, you changed it decades ago. It's just being changed back to two people.
We had exactly the same thing here in Australia, because in the 90s, late 90s, I'm trying to think when it was. Okay, it was during a Conservative government we had. Sorry, it might have been the early 2000s. My brain's not thinking exactly about right, but late 90s to early 2000s. Somebody actually tried this, because the wording within the Marriage Act was fluid enough that it could be interpreted that marriage was between any two people, because of the way it was worded, and the High Court agreed. So a rush of gay couples went to get married. So our government's response to it, and this is a lot later than happened to you, was to change the Marriage Act. And then, of course, 10 years later, we have a push for gay marriage. We could have had gay marriage, well, you know, way back when other people were having it, but just by leaving the High Court decision as it was instead of the government being absolute pricks over it. But, you know, 10, 15 years later, when we finally have a plebiscite quasi-referendum over here, the big arguments was the same issue. Oh, we can't change the definition of marriage, and that's just ridiculous, because that's exactly what you did to stop gay people getting married.
I found some really fun differences between the UK and the US in terms of how marriages work. So in the US, the actual legal marrying bit can be done by a religious official. In the UK, it can't. In the UK, it's simply an official document. You get a registrar to come along and sign, and the registrar will sit through any ceremony that you want to have produced in order to get it sorted for you, or you can just do it in the registrar's office or whatever.
Yeah.
But in the US, a pastor can actually be the one who marries you, a pastor of a church. But funnily enough, there's also, in certain places, weird rules. Like, I think it's either Texas generally or somewhere in Texas, that if you announce that you and someone else in public, if you announce that you and someone else are married and you do it 3 times, technically then you're married.
Ha!
And that's a law still on the books, though it's not applied.
That's kind of cool.
And so there's some really weird, ridiculous differences. And that, of course, kind of, you obviously then religious officials in the US need a marriage license. But here, that means we don't. So, like, I could marry 2 of my friends in a polytheist ritual if I wanted to, so long as I had a registrar for them to sign the official piece of paper.
Yeah, I mean, over here, you can have registrars and you can have marriage celebrants as well. So, and they've got the right to register marriages as well. So, like, ministers do that, and you get civil marriage celebrants as well. So,
so that sounds like you're somewhere between the two then.
Yeah, except that there is an actual... you can't just send away a piece of paper to become a marriage celebrant. You actually have to go and do a course, and you have to pass the test. So you have to actually know what the law is and everything.
That's fair.
So it's a little bit more detailed than the US, but it does enable you to have civil celebrants, and as well as of any religion can send off a minister or whatever they've got to go and get registered to be able to do marriages. It's not a particular thing for a religion, they just have to be able to do it. So, like, if you're a minister of a church, you would have done that study as part of becoming a minister. But they also get lay people in the churches who become celebrants, so they can conduct weddings even if the minister's not available. So, yeah.
Yeah.
That's
fair.
It's kind of cool. But, yeah.
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 So, something I went to say earlier, but we fell down a rabbit hole.
Yeah.
Was less as a stump you and more of a I wonder what your reaction to this would be.
Okay. Yeah.
I'm gonna read you a line from a film, and I wonder if you know what film it is, and then do you have a rant about what's wrong with this?
Okay.
The line is, "All right, I've hacked into the mainframe and disabled their algorithms."
Oh, fuck's sake. Yeah, would that be something along the lines of War Games or one of those films?
No, it was a line from Tony Stark.
It was Tony Stark. It was from Iron Man.
Yeah.
Oh God, how did I not recognize that? Yeah, I think it's because I do my suspend belief thing when I
that's
watch those sort of movies. So you have to, because of the bullshit.
Do. I sometimes do, but the other day, sorry, go on, Laura.
I was saying, as Star Trek would say, the plausibility filters are malfunctioning.
I mean, I normally suspend disbelief, but my little sister had it on the other day. I think it might actually be one of the Avengers films.
Yeah.
And I heard it, and I was like, excuse me, that's a string of buzzwords.
Yeah. I hacked into the mainframe. Yeah, you probably wouldn't actually hack in the mainframe. You might hack into a terminal to the mainframe.
Thing is, he was saying this as he sat in his suit out away from the building.
Oh, yeah. So his suit used 3G system or satellite uplink system to go through the internet, to hack into this server and disable its algorithms.
Yeah.
I've got a fun one for you. So, while we were chatting about the Star Trek stuff, I kind of went over and got the book, the technical manual for it. Of course, it's all silly stuff, really. It's not true, but they like I say, they frame it in a logical system that's that, in the future maybe they can do this, and based upon that idea, let's have a series of Starfleet laws about how stuff works. Anyway, so because at the end of the day, the Enterprise was really just a platform for the drama that would go on every week.
Oh, yeah, it was Love Boat in space.
I think it was a bit more than that.
I don't know about that. I mean, didn't Kirk used to get the girl in almost every episode?
Well, you see, the thing about it is, I never really liked this original series very much, because it was, so many times it was the same thing, just in different forms. So basically, there's something going on this planet. The Enterprise go, there's some issue, and then they solve it, and then at the end of the day, they make a joke at Spock's, just to to annoy Spock, effectively. But anyway, there was a bit I was trying to find because I thought it was funny.
Yeah.
And it says in the book, so it's got these little bits at the bottom talking about the production stuff as opposed to the science-ish stuff. So it says, early in the series, Patrick Stewart came up to us and asked how the warp drive worked. We explained some of the hypothetical principles described in this volume, but added such a device is far beyond present-day physics. We emphasise that no one has any idea of how to make a ship go faster than light. Nonsense, Patrick declared. All you have to do is say, engage. And he was right.
Yeah. See, my biggest problem with Star Trek is that it takes itself too seriously.
It's like Warhammer in that regard.
Yeah.
Like Warhammer started out as a satire of Catholicism.
Yeah.
Also, and this, much to the infuriation of a lot of my relatives, I've never seen a full Star Trek episode.
Wow.
Yeah, well, not all of them are good, to be perfectly honest.
Well, when COVID's finished, you can possibly watch it together.
Star Trek is also most of the Star Trek is very dated now. Even Next Gen and Voyager and Deep Space Nine, it's all very dated.
It's
I've
true.
seen significantly more B5 than Star Trek.
Yeah, that's quite true. The Enterprise, Next Generation Enterprise, it went politically correctly when no one had gone politically correctly before.
Okay, well, this is probably a better question for Laura because she knows Star Trek better than me. But Purple just said in TOS, the scanner over the med bay had 6 bars, but in Next Generation, the scanner had 7 bars. According to the technical manual, what was the extra bar for?
I don't know. Let me have a look. Let's see if there's an answer.
Yeah, I would agree with you on that. Never again. Looking back, a lot of Star Trek was just dreadful. But it was progressive for the time that most of the episodes came out, but it's why it hasn't dated well.
That's fair.
So they often went into social issues and things like that, and those social issues have changed to a certain degree now. So the way they did certain things would be discussing. There is an episode in Deep Space Nine where the Doctor performs a temporary sex change on a character so that that character can trick somebody else.
Yep.
Now there's something that's completely tone deaf.
Yeah, I know. I know that episode well. It's one of the ones with Quark.
It is,
and they turn him into a female called Mishka, I think. It's
Yeah.
called. And including the sex organs. So take the clothes off later, and it's it's like
yeah, and then at the end of it, change him back. It was all like, why would you do that? How is this possibly a good idea? And how is this not even considered tone deaf in the 90s when it was made?
Yeah.
Because it was incredibly tone deaf at the time, and it's even worse now.
I guess in a way, if Star Trek was kind of a bit progressive when it started, so long as it's keeping up, it's got one up on the Bible. The Bible might have been slightly progressive when it was written, but not at the moment.
Yeah. Yeah, and that's the thing. For its time, Star Trek was quite progressive. It came up with different ideas. It didn't necessarily handle those ideas well, but it made an effort. Some of those efforts fell badly even at the time, and are even worse now. So, it's one of those things. A lot of television doesn't stand the test of time. I mean, look at Doctor Who. I mean, you go back and watch 60 era Hartnell, and you're watching rampant sexism. And even through to Tom Baker, you've got rampant sexism.
I mean, even a little bit past Tom Baker, it was better, but there was still a decent.
You've probably got to get up to Sylvester McCoy before the rampant sexism basically abates.
Yeah, this is true. It's funny because there's only then rampant sexism in a couple of episodes of New Doctor Who, but they make a point of pointing it out.
Yes.
Especially with like Donna Noble and stuff, it was just like, excuse me.
Yeah. Yeah, so it's done for a different reason now. But, I mean, even modern Doctor Who is not going to age well over time because it's written to the social aspect.
Not.
It's still, I mean, if you go back and watch early Eccleston, you go, damn, you wouldn't do that now. And I mean, we're only talking 15 years.
True. I mean, I still like the Eccleston stuff. I just have to acknowledge that some of it's a bit problematic.
I looked in the manual, and it doesn't really say. It just says that they look at a series of bodily functions. But one of those little notes about production notes. It says a close examination of one of the medical displays in sickbay shows that one of the patient's status indicators is labelled medical insurance remaining.
Yeah. Medical insurance remaining. Also, in Star Trek, they had to have medical insurance. In a futuristic society where money didn't matter, they had to have medical insurance.
Well, they didn't, obviously, but it's just a joke. A joke set in because basically it's laughing at the American system, isn't it, really?
Hi, Casual Spaceman. Good to see you here.
I'll tell you one funny one that was in it. So they would use all sorts of different things to make sounds on the ship. So like like a throbbing noise that happened in the engine room, and a sort of like a kind of just in space, and there's like a almost low rumbling sound. One of the ones that happened, do you remember the episode called Tin Man, which was there was this hedgehog looking thing, and a patient of Deanna Troy's, he had too much stuff being absorbed and he was better on his own, kind of thing. Do you remember that episode?
No, I don't.
Okay, he ended up going over it, and it was basically a living ship, and it was sad. And the anyway, but the sound effect for inside that ship was this kind of just this weird noise.
Record played at the wrong speed.
No, what happened was the sound guy. He got a company called Medical Microphone kind of thing, and he put it to his stomach. So it's basically the noise your body makes. Yeah.
Fair enough.
It was just his bowels working.
Yeah, don't mispronounce your bowels. Bad joke. The warped LP of whale calls. Okay. That's an interesting description. So, yeah, well, we've got really stuck on Star Trek thanks to Jay and his wonderful question about warp drive. So the ultimate answer to that is unknown if we can ever make a warp drive. I think it's irrelevant to us. The reason, I mean, we need to become a spacefaring civilization just so we can survive long term. Our number will run out eventually. This planet will have a star go supernova and that's too close at some point, or we will get hit by an asteroid and wipe out most of humanity, or we'll have some weird stray gamma ray flash across the solar system and wipe most of life out in our solar system.
Or we'll
overfarm. We will destroy ourselves through global warming. We have to become a multi-planet species. As a part of surviving, we have to do this, which is why we should be progressing. The moon is a great first stop. It's not going to protect us from everything that could happen, but it'll protect us from a lot of it. And it's a great place to build other ships, because all those problems of, launching nuclear power systems from Earth is really dangerous, because what if the rocket blows up in launch? We don't have to worry about that as much on the moon. So if we launch to the moon, we build shipyards on the moon to build other ships. We can launch from a lower gravity, we can launch larger vessels, and we could have nuclear powered vessels that can go around nuclear powered vessels that can go around the solar system, and then we can start populating the solar system like in The Expanse,
Titan, things like that.
Yeah.
The problem that I actually think we've gone a retrograde step over the last 50 years effectively. Because if you think about it, we went supersonic, and then we went to the moon, and then we had the space shuttle and the Hubble and bits like that. But in terms of going places and doing things, we're kind of stuck. I mean, if you can you think of in the last 10 years? What have we really invented that has made a massive change in our life, in terms of technology?
The thing that's made the biggest change in our life in terms of technology would be, your two biggest things would be anything to do with genetics, and which of course spills over into all things like medicines and plant engineering and stuff like that, be it the abilities to feed ourselves, the abilities to actually improve ourselves, and technological advances in terms of computers and anything down that avenue.
Well, the computers, I mean, other than them getting faster and be able to stick them in our phones, that's really no different than 1999. I'm talking a decade. That's 20 years ago. So in 20 years, the only difference we made is that we got faster computers and we've got dial-up. That's the only difference, really. Social media, well, different forms of social media, but, what's that actually doing for the betterment of humankind?
Well, the net itself has been instrumental in the acceleration of our technological achievements because of the ability to communicate quickly. The fact that we can do this across the entirety of the planet, and you've got scientific organizations that can do this. Look at the World Telescope, and I can't remember what it's called, that took the first images of a black hole in another galaxy. And we were only able to do this because of we were able to line things up using the internet. The fact that we had larger amounts of storage now that we could. Because, we actually couldn't use the internet to transmit the data because it was so much of it. They actually had to physically take it there. But we could only do that data collection because we have the larger hard drives we have now, the larger storage capabilities that we have now. So, no, these changes have made significant improvements to our lives and to the things that we are actually able to do. The improvements in AI that have come from the improvements in computer technology have enabled us to do a lot of things, even down to improving the way that we produce materials. In material sciences, AI is often used to simulate the materials that they're trying to develop to try and help us get to the point of developing these new materials. So even like the room temperature superconductor would have probably, the concepts of it would have probably been modeled on an AI, and you wouldn't been able to do that 15 years ago, 10 years ago even, because of the exponential growth in computer power that we've had. So those changes, whilst you're saying, what's the real difference between what we had now? The real difference is the computer that's in your phone is better, is more powerful than the desktop computer you had 20 years ago.
Absolutely true.
That's
but really,
the difference.
has that but is that really anything different than making it smaller and more powerful? It's still not making any difference. We're still not going to Mars, and
Yeah, but you're looking at two different aspects of technology. I mean, we have the technology to go to Mars. Do you know why we don't go to Mars?
Because it's expensive.
Well, there's more than that. It's not just a case of expense. If it was just expense, I think we'd probably do it. But the reality is, there's only a handful of things that we can do by going there physically ourselves that can't be done by the machines that we send there. And sending people there is dangerous.
Yes.
It is a very long trip. We're looking 6 to 12 months in the openness of space without the shielding protection from the Earth's magnetic field that stops cosmic rays from getting to us and hurting us. Now, you are looking at when the Apollo astronauts went to the moon, they got the equivalent of a couple of years worth of X-rays during the trip there and back. Going to Mars is worse. A lot worse. So the dangers to the astronauts themselves going to Mars, plus the fact that Mars does not have a substantial magnetic field to protect you once you're there, and that there's no resources there for us to actually go and use. We have to take everything with us to start off with. Makes sending people to Mars is incredibly dangerous and complicated. Way more complicated than those short little trips to the moon we did. And those short little trips to the moon, whilst we did them, that was a Cold War issue. The only reason that even happened was because America and Russia were sprucing their muscles and saying, hey, we can do this first, rah, 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 we're better. And it was America feeling the pressure of being left behind when the Soviet Union put the first satellites in space. It was bigger and better and leapfrog. And when Russia eventually pulled out of doing the manned space things to the moon and that, NASA did a little bit more, and then it was like, no, we're pulling funding away for it because there's no competition here. So it makes more sense to send robots, to send something we're not risking human life. Because even sending people into low Earth orbit risks human life. As we know, we've lost quite a few astronauts in launch procedures with NASA and stuff like that. So I guess the question would be, why are we even sending people to low Earth orbit is a better question than why haven't we sent people to Mars? And
it kind of deals with what you were saying, though, because we are one asteroid collision away from being wiped out.
I think...
And the idea of going and putting settlement on other planets is a necessary thing to do.
It is, and I agree with you. We need to do it. But the point is, the reason we haven't done it is the risk of failure, and the technologies we had when we went to the moon don't cut it for doing long-term stays on the moon or on Mars. We've had to develop better technologies. We're having to develop better launch systems that are more reliable and more stable than the ones we were using before. We can't just riskily strap a crew capsule onto the top of basically a bomb, which is what we do. We still do now, but what we have to have is evacuation procedures for that have a chance of working. That's why SpaceX spent so long testing their emergency capsule recovery system for if the ship explodes. These things are important. This wasn't done during Saturn. If the Saturn V blew up, you lost your crew. You lost everyone you were sending. You lost everything. That risk to human life, it wasn't worth it when we could send robots up there that could do 90% of what a human could do for the studies that we need at the moment. The problem we have now is we're getting to the point of the studies of certain places for example, the Moon and Mars, where we're needing to send people back because we need that faster interaction and we need that human intuition on the spot. So we're getting to the point that we may need to send people, but to send them, we're going to have technologies that are safer and better, because rushing it and just shooting people out there, we're going to kill people, and we're going to kill a lot of people in doing it, and that's not acceptable anymore.
Yeah, I'm not. Sorry, go on, Sam.
I think the thing is that while it might seem like flying to the moon and then flying to Mars are very, very similar, that's like saying sailing from England to
France.
Ireland is
France.
is the same as trying to sail from England to Australia or to America.
Yeah, it's a very different proposition. The
technology gap required is massive, and it requires a massively long time from one to get to the other, because while it's the same tech, the ability to use it has to increase dramatically.
Yeah, I'm not disagreeing with you. I think what I'm trying to say is that the impetus to expand is, effectively the drive isn't happening in the way it used to. So, it's like effectively the only way we'll get to Mars will be if we have an incentive to do it. And
you're talking about the whole war pressures thing, because typically in the past, innovation has been fueled by war or conquest, and we're reaching a point where that's not applicable anymore, and it is for the science's sake.
Well, effectively what I'm trying to say is the development of the going to the moon, it went through sending up empty capsules and rockets that exploded on the pad, and then went to Mercury, and then went to Gemini, and then went to the Saturn system. So it was a sort of development, and the only reason I had that happen is because there was the Cold War. We can't let the Russians get there first. And 1957, October the 4th, was the launch of Sputnik, and that changed everything. I mean, they were going to build loads of fighters over, for sort of the north part of North America, Canada and northern United States. Because they were, when World War III happens, the Russians are going to come over the pole and they're going to get us that way. And as soon as Sputnik went on, it's like, okay, we need to find ways to, destroy their missile silos and things like that before they can get to us, before they can even launch them. So there was the drive to make this happen. Well, so the idea of going to Mars can only really go, that development element of it can only happen if we say, right, we're going to go to Mars. How do we achieve these obstacles? And I've got an example of something I thought about years ago, and it's something, again, it's at the moment certainly in America and Europe, sort of America first, says Trump. The idea of cooperating with each other to find solutions to things isn't happening. And I had this wonderful idea for energy. So we have an energy crisis. Effectively, we're poisoning the atmosphere, and we need to find a way to have clean energy, and it's cheap as well, because those are the two primary things. So I had this wonderful idea. So in World War II, America saw a danger, and they got the smartest people they could get, put them in basically a town that they made in the desert, Los Alamos, and they created the nuclear bomb. Now, they had scientists from all over the world, Australian, American, British, Canadian, all sorts of people from different parts, all basically putting their minds together to how do we achieve this goal? Well, that was a destructive goal eventually, because it was a bomb. But could you imagine, instead of having loads of different countries developing, their own energy, research systems. I mean, when I was a kid, the thing about cold fusion. Some scientists saying, "Oh, we think we can do fusion, but not, having to create a lots of heat energy to do it." And of course, everyone's like, "Oh, this is going to be great. This will be great," but it never really happened. It didn't work. But that group of people, it's only a small research facility. They're still working on it, from what I read a few years ago. Now, if you got them, and you got all the different countries, all the smartest physicists across the world, and you got them to pull their resources, pull their talents, because what happens is, let's say, some scientists from China, we're trying to achieve this, but we can't get this to work. Some scientists from China said, "Well, have you thought about this?" And next thing you know, there's your eureka moment.
See, I think you gravely misunderstand how the scientific community works there, Laura, because that is how the scientific community works. They do talk to each other. They do share ideas. The scientists themselves will talk with their colleagues. They will communicate together. They will look for help from other people if they're stuck on an issue. And this happens across the world. The boundaries that we perceive as being political ones don't necessarily exist in the scientific community. I mean,
look at CERN.
Yeah.
CERN has scientists from, I think, most, if not all, countries. And they are kind of onto themselves a lot of the time. And a valid... you can get like a valid Switzerland visa, I think, simply for the purposes of visiting CERN.
Yeah. I mean, you talk about differences between like a communist country like China and, say, Australia. There are Australian scientists who are helping China with their own experiment for working with nuclear fusion. So that international level of cooperation is actually there in the scientific community. It's not a case of, oh no, they're all in secret doing all these things separate. Yeah, some of the time, depending on how the funding is coming in for it, at a certain level, it's going to become secret because there are patents and law and things like that are involved with some forms of technology. But scientific discoveries and development of new theories and ideas that help generate that engineering levels of development, generally speaking, are more open. You will find on papers written by somebody in the US that there will be people from Europe, from Japan, and from China who've contributed, because that's what the community is like.
The difficulty in my head is that they're foreign employees for them, and I just think it would be advantageous for the world, because I mean, let's just take one conflict that's going on at the moment. Let's take the Iran deal. Trump's pulled out of it, and it's like, well, they're claiming that the only reason they're doing it is to create a nuclear power facility. Now, if we get them on the team that's going to create this energy thing, then it kind of diffuses such things. I don't know. It just seems to make sense that rather than having independent laboratories in different countries working on a similar project but not the same thing, and of course any things that they don't know, someone else might.
Yeah, the point is, you're talking about literally millions of scientists across the world who want to live in the areas they live in, and they work in those areas because that's where their families are, that's what they do. And then they use the internet, this beautiful thing that we have now, to communicate to each other and share ideas across things. So even if they're working in different labs, different scientists who are working in similar fields will share ideas, will share things that they've discovered, and it helps them all develop towards newer things. And science relies on confirmation. So having multiple people working on similar projects is a good thing, because otherwise you just have this one group that goes, we discovered this, and no one's confirming it. By having multiple people come out with the same things but using different methods to get there, you're confirming the scientific data. And that's part of how science works.
Jen, I'm the awkward person in the middle of you who says, I agree with you, Jen, up to a point.
Yeah.
But I think that with the practical application of things, Laura is sort of right, because you'll get companies filing patents and hiring scientists and making them sign confidentiality agreements.
Yes, you do get that.
These different things, which and governments do this as well. When I say companies, governments are basically glorified companies.
Yeah, you realize that a good 80% of the discoveries that come into our world that are developed are actually developed by universities and not by private companies.
Yeah, and that's why I said up to a point I agree with you.
Yeah.
Like for the majority of the time, yeah. But with a lot of the practical application stuff, it becomes significantly more difficult. That line starts to blur, and you do start to get into questions.
You do, but that's at the later stages of it. The initial development of a technology or for a technology, it is generally at the university level, somebody with a basic idea, and then that's often shared. It's the finishing of the product that becomes the hidden IP that you have some confidentiality agreements for and stuff like that. It's why you can have multiple companies come out with a very similar product, and they've both got separate patents because they got there in a slightly different way and whatever. So. But when you're talking about the development of theories and advancements in science, that is more open because that's generally government funded or university funded, and it's funded by multiple governments, especially if it's a big enough project similar to CERN. So breaking down those boundaries of science and coming up with new ideas and new developments in science is more open than the side that is the commercialism of science. And unfortunately, you have to have that commercialism. At some point, you're going to have it because you have to be able to pay for all of this. So the only reason why you have big companies throw money at universities is that in the hope that somebody there is going to develop something that maybe the university can buy from the company can buy from the university eventually.
Yeah, and I think the other thing is we don't always produce the things we have the tech to produce.
Yeah,
because the cost is too high. And to let the leftist out of the box for a minute, what if global socialism?
Yeah,
then we could actually between us all fund important projects that no individual company is going to fund by itself.
Yeah, I mean the world is moving towards more public funding for things, as in the advent of the online funding for where people Kickstarters and things like that is moving in that direction where you're actually unfortunately people are abusing Kickstarters, but in general we're moving towards a public funding sort of arrangement where things will be hopefully more shared, although people want to make money out of them, obviously.
I've got something for you, Jen, that I was listening to your word game. Was it yesterday or the day before now? I can't remember. And one of the things that you said you were thinking about going back to university to study psychology.
Yes.
I study psychology at college level, but I'm not university level. And one of the things that I learned, which kind of relates to what you're talking about scientists replicating each other's experiments to, one of the things I was told about psychology, for an experiment to be scientific, it has to be it has to be replicatable, objective and controlled.
Yeah.
So I'll leave the first one to the end because that relates to what you were talking about. The objective part is you put down a hypothesis. I think this might happen. So you set up a system and you do what the system is.
Yeah.
Goes through. So it's like you're not trying to. So the objective part is, I think it'll do this, but you have to be objective because you don't want to start changing things, because it's not going the way you think it's supposed to go.
Mm.
So the idea is, let's set up this thing and see what happens. And the controlled part is, don't go changing things because then you're going to end up with things changing because you haven't got everything the same each time. So, for example, let's say, just using a normal scientific, how long does it take for a piece of chicken to go rotten? Well, if you have a fluctuating temperature in the lab, well, that's going to change the parameters. If you leave the lid open, then that's going to have a different reaction because flies can get to it and so on. So all these different factors, unless you make sure it's done in a specific way, a controlled way, it'll go wrong. But the replicable part is the idea that so you're another psychologist. I've come up with an experiment. So what happens is I lay down how it's done, and you try it out yourself. And then, well, if it's replicatable, you should come to exactly the same results. But if it's not replicatable, if things have left bits out that maybe were important, and you aren't able to replicate it, you can say, wait a second, this hasn't worked. And this is where the Andrew Wakefield thing came along, who said, MMR causes autism. Let's forget that his experiments were unethical. But when other scientists tried to replicate the claims he was making, they couldn't find, it didn't work. It didn't happen the way he claimed. And that's how it was. I've actually got a video on my channel with the journalist Brian Deere, who blew open the conspiracy behind it.
Yeah.
And do you know what a PCR test is?
Yeah.
For those people who don't know, it's a machine, and it heats up samples. So, when you heat it up, it will replicate. It will make a copy of it, and another copy, and another copy, and it will just, well, if you've only got a tiny sample, you put it in this machine, it heats it up, cools it down, heats it up, cools it down, it replicates more of it, so you've got enough material to test. What Wakefield did was lower the bar for the PCR test, so that it picked up the background stuff, background levels, not the spike that would happen if it was set properly. So just to give an analogy for this, think of a Geiger counter, and when it gets over, let's say 10, just using a round number, if it gets above 10, that's an indication of there's bad levels of radioactivity. That's when the noise thing starts clicking a lot. Whereas below 10, that's background radiation. That's just the sun coming, through the atmosphere and things of that nature. So bananas. So what happened was he lowered the bar so it was below 10.
Yeah.
So instead of clicking only when there's lots of radiation, it was clicking when there was all the time. So
his P levels weren't good. So
sorry,
yeah, but scientists actually shift their there are lots of people who don't do good reporting in their scientific studies.
Oh, you mean creationists?
Sorry?
Creationists.
No, not just them. There are legitimate scientists who really just don't care about the levels, their distribution levels, their statistical relevance of their results, which is what your P levels are about. So if you're not statistically relevant, then your study is basically pointless, which is what comes out of that study that was done about trans women and muscle changes over 12 months, where they studied, what was that, 13 trans women for 12 months, and the P level, the difference on the P levels, the P level in that is such that it's statistically not relevant.
What was the P? What does P mean?
It's a ratio of distribution. So like if you've got a standard distribution, if something's going to be relevant, it'll have a higher p level, so it'll be outside of what would be the normal bell curve. So what you had is, because you had such a low number of people within that particular study, and you had a reasonable swing in variance between it, and you didn't do the proper underlying control of the underlying variables, your p level ends up right smack bang in the middle because you didn't do your study properly. But they changed the way that they calculated their p level to make it look better. That's the problem with that study. It's a problem that you often get with studies where you don't have enough subjects for the study to be statistically valid. And then you just have to jerry-rig your p-levels. But jerry-rigging your p-levels to try to show that you've got something outside of the normal distribution is just screwing with the maths, basically, to try and get a result. And, you know, you just can't do that.
Statistics can say anything if you're clever enough.
Oh yeah, which is right. Well, I mean, which was fine for the initial point of the experiment. The point of the experiment was just to see what the change, to get an idea of what the changes with hormones would be over a given period of time. Problem with that, which was fine. The problem with that was when they tried to, when rugby, World Rugby tried to use the results from that study, which is what they have done, to justify their banning of trans women in international sport, international rugby. And that is the whole problem with that decision, is that it's based on a study that does not have a significant p-level deviation to a significant deviation from the normal for it to be considered in that way, especially when it wasn't even about people who were athletes anyway. But that's beside the point. There were so many methodological problems with that. For its original intent, it was fine as a first attempt. For what they ended up using it for, it was not, which is often the case. And this is the problem this is the worst problem you can have in science, in that you can have what could be considered a justifiable and a good experiment that is then misused because people misunderstand the bounds of the experiment. The one that really annoys me about this, it was that actually one of the people who was an author on the paper that misused the experiment, and that pisses me off. So
the Andrew Wayfield videos I was mentioning, yeah, could you mind if I put them in the live chat?
Yeah, you can put them in the live chat. You've got mods, so yeah, you can do that. Yeah, so I believe that Robert X was talking about what we were talking about before with the reasons why you want different centers doing similar experiments is for proving the validity of the hypothesis, and you need that. So putting everyone together in one area is going to end up with a lot of people having ideas that are basically engineered to go in one direction, because you need people to be able to think differently about the same aspect and study it separately without having interference from each other, because seeing what other people are doing is not always the best way to confirm a result. And you're going to argue with me about that, Laura, because you say, oh, but you repeat. Yes, an experiment has to be repeatable, and that's what peer review is about. But if you're going to support it by a different experiment, that actually offers more weight to the hypothesis. So multiple experiments coming at it from different angles, supporting the same conclusion, will support that hypothesis into the point of you being able to say that it's a fact or it's going to lead to a theory. So this is why having that separation of people and not shoving all the scientists who are interested in the same field in the one room is actually a good thing. I see where you're coming from, in that if you put them all together, we might get things happen quicker. We will also get the fact that we're not having enough people think in enough dynamically different ways.
Yeah, I mean, when it came to the I forgot what it was called now. It's the Large Hadron Collider.
So
yeah. The cost of building that machine was so high that you couldn't really have any counter. You couldn't say, okay, you try to replicate it, because they'd have to build their own machine, and again, it costs an absolute fortune.
Yeah.
So in order to make sure that they could have it repeatable, replicable, was to have two teams that did the same job, but they weren't allowed to work together.
Yes, they did that. There's actually more than two teams, and there's more than one insertion point within the Large Hadron Collider, so that you can actually completely separate what people are doing, and you get different run times, and you've got different labs that actually do different things by inserting and extracting stuff from the Large Hadron Collider at different points in it.
They've got loads of different teams within CERN.
Yeah.
I only know bits about CERN because we did a physics trip there.
Yeah. The thing about that is, just because you've got lots of different people sharing a facility doesn't mean you've got them all working as in doing the same things, which is where you get your independence of data, and you get your independence of ideas and applications for it, which is why you like looking for the Higgs boson. You have multiple teams doing lots of different experiments that were looking for it in different ways. You was all using the same hardware, because it's the only one of its type, but they had different sets of detectors. They were looking for things in a different way. They were accelerating atoms at different rates and into different substrates. So there was variances in the way the experiments were done that enabled them to get different results, but results that converged on the same answer. So that way you could confirm what was happening, and you also confirmed it by doing lots and lots and lots of different tests, and lots of different organizations and groups looking over the data that came from those tests to confirm what they were saying they were seeing in the data. So it wasn't really just about one place doing one thing. And yeah, if there'd been enough, I mean, even some of the minor things that were done within the Large Hadron Collider, some of the upgrades that have happened to other accelerators, not for searching for the Higgs boson, obviously, but some of the other things that they've done tests on, some of the other colliders around the world have had expansions done to them because of more improved modern technology, and they've been able to confirm things that were done at the Hadron Collider several years ago. So there's still this aspect of confirming. The Tevatron, is that the one? Yeah.
See, the other thing about CERN is that saying it's the Hadron Collider is a bit misleading, because there's actually several Hadron Colliders of different sizes within CERN.
Yeah, there's several different colliders within CERN itself. There's multiple loops that can be used that pull things off in different things, and there's different buildings that you can get. You can actually exit the particle beam from to go into different collectors and stuff like that. One of those experiments is with antimatter, because you can use the particle collider to create antimatter. And they've got their own room, and they've got their own shaft off the tunnel that they can direct the matter stream down to generate the antimatter. So yeah, there's the thing is, you've got this large accelerator that everyone can use, and then you've got various different organizations that tap off it, and they all get different. It's like multiple people. You've got this beautiful space telescope in the Hubble Space Telescope, and later on you'll have the James Webb Space Telescope for visual, and you've got all the other telescopes that are up there, and I'm not going to remember all the bloody names, so I'm not going to go through them all. And then you've got the big ground telescopes as well. Now, what happens is there's only so many of these machines compared to astronomers who use them, but they get different amounts of time to use these bits of equipment to look at the things that they're studying within their fields. And they will share data. So if somebody is doing an experiment that's looking at this particular part of the night sky or this particular star system, but there's another group that's doing an experiment based on that, but it's on about something else, the data that this group collects, they'll give to the other group, because they might find the things that they need in their data. And they will share the time, and they will share things, and so that they can study it. So the equipment we use, because it's so expensive and a lot of it is very unique, is shared, but there's large numbers of different groups that use it.
By the way, Sam, don't forget to flush. Because the last time he spoke, it did sound echoey.
Yep. So anyway, guys, we've been...
Actually, I've not. I've buggered off downstairs to get another cup of tea. So.
Okay. Well, I was thinking, given that we've this stream's been going for about 2.5 hours now,
What?
I might, yeah, I might wrap it up now. My computer's complaining at me because it wants to reboot and do an update. That's going to be really, really, really annoying. So I'm thinking we might wrap it up here. I want to say thank you to Sam and Laura for joining me. Do you have anything you guys want to shout out about stuff you're doing?
I've got something. So I play a game called Elite Dangerous, which is basically a space flight sim.
It's Elite.
Yeah, and I mean, I played the original Elite from 1984, and I was a beta tester for this version of Elite called Elite Dangerous.
The original Elite. Now, how old were you when you played the original Elite?
About 10.
About 10.
10 or 11, yeah. That kind of
yeah,
age.
I was not much different in age.
And I played it on the BBC B at school.
Oh, okay. Commodore 64 at home. That's how I played it.
Yeah, I had Commodore 64 at home, and then there was a BBC B at school.
I've got a Commodore 64 sitting right up there. And another one in a box under my bed.
Yeah. And then on the Amiga, I played
Elite Plus.
No, that was still the 16. What was it? No, I forgot what it was called. Anyway, it doesn't matter. The no, I played Frontier Elite 2.
Yeah,
it was called.
Okay,
and they did another one, which was the same thing, just with some extra bits, which is called First Encounters. But anyway, so I watch. There's a guy called Isononia who makes some really good videos. It's like a story instead of just having a live stream with someone playing the game. He basically edits it and turns it into a story, and I've always found that very appealing. And I'm thinking about doing something similar.
Cool.
Just travel around, do stuff, and have it as a story instead of, just live streaming, which everybody else does on Twitch and so on.
Sounds interesting. Cool. Oh, so that's something we can all look forward to. Go sub to Laura if you haven't. I'll let you put your own link in.
Yeah, sure.
You have put your links in anyway, but because to your other videos. But yeah. Sam, what have you got coming up? Because you've got a lovely little YouTube channel too. Please go sub to Sam.
So I have a video coming out later today, if I get it finished, and a video coming out next week. The video later today is going to be talking about anti-theism and why I think both the term and the concept are really unproductive and also slightly hypocritical. Hate the sin, love the sinner, anybody?
Yeah.
and then next week I'm going to talk about necromancy in the Bible.
Oh, that's a good topic for Halloween. That is a really good topic for Halloween.
Yeah, and October.
I did a biblical reading last Halloween of Revelations just to demonstrate how fucking creepy it is.
Revelations is great.
But it is fucking. If you read it right, it's fucking creepy.
Read it high. That's the best.
Yeah.
Well, I'm looking at it, and I am wondering if, not necessarily explicitly, but like upwards of 20% of books in the Bible might mention necromancy.
Oh, yeah. Yeah, there's a fair bit of things about magic, and the Bible's full of bloody magic. The whole world was created with magic, don't you know?
Yeah, and see, we've got everything from a rule in Leviticus, do not consult necromancers, all the way up to Jesus being a necromancer.
And Jesus was a lich.
You've also got the idea of, don't curse people, which a lot of people seem to think is don't swear, and it isn't.
Basically, it's a Hebrew word meaning poison. Don't poison people.
Yeah, well, effectively, it's don't say things like, may the fleas of 1,000 camels infest your bed or something.
No, that's more of our interpretation of curse.
Yeah, that's kind of turning into witchcraft now. kind of thing. So
which is more my area.
By the way, a little interesting thing about me. So when I first sort of discovered that I was trans, one of the first things I made was a fancy dress costume, and it was Alice in Wonderland. And I've still got it now. However, I'd have to slim a little bit more to get in.
Fair enough. Cool. Anyway, thank you to both of you. Please go and sub to Sam and to Laura. If you want to shove your link in the chat, Sam, go for it. I think I opt you. If not, I'll mod you.
Yeah, you've given me a spanner.
Yeah, I gave you a spanner. You got spanners. So I want to say thank you again to everyone in the chat who's been here for the long time. Purple, I don't know how you've done it given how tired you are. Go and have some sleep. We love you. And yeah, thanks for watching. With me, should be on Media Musings tomorrow night on One Ring's channel. Well, tomorrow night my time, tomorrow morning US time, midday-ish, late afternoon-ish on in the UK. That is. Hopefully, if I get a chance tomorrow, I will be recording another video. If my voice lets me, it should be able to. I'm sort of getting through stuff now. So, yeah. So keep an eye out for that stuff. As said, thank you all, and I'll catch you next time. Bye.
Bye.